Okay, today my group will present about ultrasonic transducer. Uh, the member is me, Nathania Hillary, and Valleta Jovanka. Next, for the contents that we are going to explain is introduction, ceramic components, main function. Next, crystal structure, fabrication techniques, and raw material resource. Next. So, ultrasonic transducer are electronic components that can convert electrical energy into mechanical energy in ultrasonic sound wave and vice versa. Ultrasonic sound wave are sound waves that humans normally cannot hear because the frequency of ultrasonic wave is above 20 kilohertz. The ultrasonic transducer in its application is always in pairs, namely an ultrasonic transducer function as a transmitter and ultrasonic transducer as a receiver. Next. So this is the ultrasonic transducer construction. The active element of the ultrasonic transducer is piezoceramic element, which function to convert electrical energy into mechanical energy in the form of ultrasonic sound wave. The backing is also aided, which function to control or dampen the ultrasonic frequency vibration from the piezoelectric active element, so it does not penetrate the back of the transducer, so that the ultrasonic energy radiates only forward. Next.
Ultrasonic transducers consist of multiple layers of material such as an active element, which is piezoelectric disc, backing element, quarter wave matching layer, and sometimes an additional protective wear plate, which are all adjoined together. In this apparatus, piezoelectric ceramics are used as a basic component of piezoelectric discs, which has the function of assisting the conversion process from electrical energy into mechanical energy in the form of ultrasonic sound waves. The selection of this material is based on its ability to allow the direct generation of electrical signals from the application of pressure and the direct generation of pressure from electrical signals. In general, piezoelectric ceramic is a term used to describe ferroelectric ceramics that have piezoelectric effect due to the polarization of polycrystals created by combining oxide, which is zirconia, lead oxide, or titanium oxide, with high temperature sintering and solid reaction. It is a smart material that transforms a mechanical effect, such as pressure, movement, or vibration, into an electrical signal and vice versa. Next. Through their properties, piezoelectric ceramics are considered to be the most favorable for ultrasonic transducer, since it presents the widest variety in their elastic, electric, and piezoelectric constants. Furthermore, the ceramic materials can be formed into a large variety of shapes and sizes, and the polar axis can be directed according to the geometry and vibration mode. Ceramic composites constitute a variety of ceramics, which seems to be very significant for certain applications. In recent times, the most suitable and popular ceramics materials are lead zirconate titanites, or PZT, of which various commercial versions are manufactured in different countries. There are also commercial compositions based on barium titanate, lead metaniobate, and sodium niobate. Next.
Okay, for the main function, the ultrasonic transducer is one type of sound-related sensor. This transducer transmits electrical impulse to the item, and when the signal contacts the item, it returns to the transducer. This transducer measures the distance of the item in this process rather than the strength of the sound. Next. For the work principle, when an electrical signal is supplied to this transducer, it vibrates with a certain frequency range, resulting in the generation of a sound wave. This sound wave travels, and anytime an obstruction appears, this sound wave reflects the transducer echo information. This echo is converted into an electrical signal at the transducer end. The transducer then estimates the time elapsed between admitting the sound wave and receiving the echo signal. Next. And for the crystal structure, each perovskite crystal in the ceramic element display simple cubic symmetry with no dipole moment at a threshold temperature, or it's called the Curie point. From the figure is in the left one. However, at the temperatures lower than the Curie point, each crystal exhibits tetragonal or rhombohedral symmetry and a dipole moment. From the figure, it's on the right. A traditional piezoelectric ceramic is a mass of perovskite structure, each consisting of a small tetravalent metal ion, usually titanium or zirconium, in a lattice of larger divalent metal ions. Next. However, because the direction of polarization across neighboring domains is random, the ceramic element has no variable polarization. It's on the left figure, and a ceramic element domains are aligned by exposing to a strong direct current electric field, usually at a temperature slightly below the Curie point. From the figure is on the middle, and the last one, when the electric field is eliminated, the majority of the dipoles are locked into a near aligned state, and from the figure is on the right. Next.
To produce piezoelectric ceramic, fine PZT powders of the component metal oxides are mixed according to the proportions, continued by heating to form a uniform powder. The piezo powder is combined with an organic binder and is formed into structural elements having the desired shape, which are discs, rods, or plates. The piezo powder particles sinter and the material attains a dense crystalline structure when the elements are fired according to a specific time and temperature program. After cooling, the elements are shaped or trimmed to specifications, and electrodes are placed on the appropriate surfaces. The whole process is illustrated in the flowchart in the following slide. Next. So this is the manufacturing process in a more detailed flowchart version. The process of manufacturing PZD powders consists of 6 distinct unit operations shown in the figure. Throughout the world, high purity raw materials are evaluated, selected, and sourced. Material activity and limits on specific deleterious impurities, in addition to purity, are used as selection criteria. After each material has been chosen and approved for use, it is precisely weighed and transferred to wet mills according to the formulations being manufactured. To achieve a uniform particle size distribution, these ingredients are wet milled together in their proper proportions. In addition, to ensure proper material activity during calcination, precise control of particle size distribution is required. The product is dried and prepared for calcining after the wet milling process. To ensure that the final product is free of chemical contaminants, it must be calcined in high purity crucibles. The calcining operation is carried out in air at about 1000 degrees Celsius, where the desired PZD phase is formed. Next. A traditional piezoelectric ceramic is a mass of perovskite ceramic crystals, each consisting of a small tetravalent metal ions, usually titanium or zirconium, in a lattice of larger divalent metal ions, usually lead or barium, and O2 ions. In Indonesia, titanium deposits are described into a few deposit types such as beach placer, alluvial, and lateritic. Lateritic titanium deposits can be found in association with bauxite and nickel in Riau, Kalimantan, and Sulawesi Island, where its source is granitic and metamorphic basement rocks. Sumatra shows a significant resource of lateritic titanium deposit that is up to 100 million tons, with 0.5% to 15% titanium oxide, which is a huge increase from the deposit in Bintan Island in Riau that is around 20 million tons. Sumatra has both beach placer and lateritic deposit type, with beach the amount of beach placer deposit lower compared to lateritic ones. In the meantime, Sulawesi lateritic deposit value in titanium oxide is up to 31 million tons with titanium oxide of the content average of 9.85%. For beach placer, Java resources are quite big in tonnage, reaching up to 50 million tons in total, with significant titanium oxide contents ranging from 8.91% to 3.17%. Beach placer along the south shoreline of Java seems to indicate consistency in their mineralogical and genetic types with relative homogeneous in titanium oxide contents. Other than titanium, lead is also found in Indonesia, precisely in Karimun Gojo, Kalimantan, which is mined by PT Kapuas Prima Coal. For zirconium, the country with its highest reserve is Australia and South Africa, while Indonesia is claimed to produce 8.02% of world zirconium, which is around 175 million ton. Next. And that is all from our presentation. Thank you for watching. If you have any question, feel free to contact us. Thank you.